calculating the frictional force. So, if you're going to calculate the frictional force, you need to know that friction depends on two things. So, the first thing is the amount of force acting between the surfaces, or the normal force. So, obviously, you already know from experience that if you're trying to move something heavy, there's more friction involved. Rather than something light, there's less friction involved. The second thing is the nature of the surfaces. So the coefficient of friction. So are the surfaces really smooth, or are they really rough, or is it kind of in the middle? And there is this equation that we're going to be using to solve for frictional force, or maybe you'll have to solve for the coefficient of friction, or maybe sometimes you have to solve for the normal force. So frictional force is equal to the coefficient times the normal force. So normal force. When we say normal force, you need to know that it is equal to the weight force when the surface is horizontal. So this box on the table, the weight of the box is a downward force of 80 newtons. So that means the normal force is equal and opposite, so it's going upward. The normal force is 80 newtons. All right, the coefficient of friction. So we've talked about coefficient of friction describes how rough or smooth the surfaces are. So if it's a rough surface, that coefficient is going to be greater than 0.5. And if it's a smooth surface, it could be lower than 0.5. All right, so the frictional force is the product of the coefficient of friction and the normal force, represented by this equation. So you have frictional force, F, is equal to the coefficient of friction, mu, times the normal force, Fn. So let's do two example problems. So we're going to solve the frictional force of this box with an applied force. So as you can see, this box weighs 5 kilograms, and we are applying 15 newtons of force to try to move the box. So there's a 5 kilogram box on a horizontal table, and it's being pushed by a horizontal force of 15 newtons as shown on the right. If the coefficient of friction is 0.4, so it tells us that the coefficient is 0.4, will the box move? So let's get started. Well, first we need to know the weight of the box. So we have the mass. It tells us that the mass is 5 kilograms. So remember, to find weight, we need to do mass times gravity, because we only have weight because our mass experiences the gravity of planet Earth. So we're going to take our mass, 5, and multiply it by gravity of Earth, 9.8, and we actually get that the weight is 49. So on our free body diagram down here, our downward force, weight, is equal to 49 newtons. Second, now what is the normal force? Because you know that we need the normal force for solving this equation. Well, normal force is opposite and equal to the weight. So the weight is going down, the normal force is going up. The weight was 49, so that means that the normal force is going to be 49 newtons. Third, now you just need to plug in your values to the equation. So the frictional force is equal to the coefficient, and we said that the coefficient was 0.4, so we plugged in 0.4, and we found that the normal force was 49. And so that means that the frictional force is 19.6 newtons. So that means over here in our free body diagram, where we have friction, we can actually plug in that 19.6 newtons of friction is being observed on this box that we're trying to move. All right, so remember, the pushing force is 15 newtons. The applied force is that 15 newtons. So we're trying to push with 15 newtons, but friction is actually 19.6 newtons. All right, so that means that the box is not going to move. Our frictional force is stronger than our applied force. So we can't move the box because there's too much friction. All right, let's look at moving this trash can. So the trash can, a dustbin, has a mass of 12 kilograms. So we know the mass is 12 kilograms. And as you can imagine, we are going to have to convert that mass and figure out what the weight of the box of the trash can is. So it's standing on a horizontal ground, and it is pushed by a horizontal force of 48 newtons. So this diagram should say 48 newtons is being pushed. All right, if the coefficient of friction is 0.4, will the dustbin move? So we still have, again, the coefficient of friction is 0.4. All right, so first, what is the weight? Well, we already said that weight is equal to mass times gravity. So our mass was 12, our gravity on Earth is 9.8. So we get that the weight is 117.6 newtons. So I'm just going to write 118 newtons. That's our weight. So we know that the normal force is equal to the weight. So we know that our normal force is also 118 newtons. All right, now we just need to plug in our values. So the frictional force is equal to the coefficient, and the coefficient was 0.4. It told us that in the word problem. So the coefficient is plugged in to be 0.4. Our normal force we said was 117.6. So we plug that in there. When we multiply these two numbers, we get that the frictional force is equal to 47.04 newtons. All right, so remember, we are pushing with 48 newtons. So we're pushing with 48. The frictional force has a magnitude of 47.04. So the box will move because the applied force, so the pushing force applied, 48, is greater than the frictional force of 47.04. So, yes, it's not greater by a whole lot, by 0.96, but it is greater. So because the applied force is greater, this dustbin, this trash can, will end up moving.